All. Our next topic is Fourier transform and inverse Fourier transform. This is also like Laplace transform. The transforms are mathematical operators used to convert a type of function to another type of functions. We already studied Laplace transform. In that case, L of f of t, the function of t, changes to function of s. L of f of t equal to f of s. We denote that by f of s. So, the variable t converts to function containing variable t converts to a function containing variable s. So, transforms are used to convert a function to another form. Here, Fourier transform. Let f of x be a real function which is absolutely integrable. Absolutely integrable means integral minus infinity to infinity mod f of x dx, that value less than infinity, and piecewise continuous. Then the Fourier transform of f is the function f of omega. Here Fourier transform is denoted by f of omega and defined by f of omega equal to f of x, which means Fourier transform of f of x, and its definition is 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Okay, so study this. This is the definition of Fourier transform. f of x equal to 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Conversely, the inverse Fourier transform of f of omega is defined by f inverse of, denoted by f inverse of f of omega equal to 1 by root 2 pi integral minus infinity to infinity f of omega e raised to I omega x d omega. Here the function in terms of x converted to a function in terms of omega. Next, consider a problem. Find the complex Fourier transform of f of x equal to e raised to minus kx if x greater than 0, k greater than 0 and 0 otherwise. Here the Fourier transform is f of x equal to, first write the definition of Fourier transform, 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Here f of x is given e raised to minus kx in the interval x greater than 0. So, here the interval changes to integral 0 to infinity e raised to minus kx e raised to minus I omega x dx, and this is of the form a raised to m a raised to n. So, combine that a raised to m plus n, then integrate that term and substitute the limits. We have the Fourier transform of the given function as 1 by root 2 pi into k plus I omega. Next, similar way, do the next problem also. Next, consider the third problem. Find the Fourier transform of f of x equal to 1 minus x square where mod x less than 1, 0 and mod x greater than 1. Using inverse Fourier transform, show that integral 0 to infinity cos omega by 2 sin omega minus omega cos omega by omega cube d omega is equal to 3 pi by 16. There is two questions. First, we have to find Fourier transform, and using inverse Fourier transform, we have to prove this inequality. Prove this equality. First, write the definition of Fourier transform. f of x equal to 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Here f of x is 1 minus x square and the interval is mod x less than 1. Mod x less than 1 can be written as minus 1 less than x less than 1. So, the interval is from minus 1 to 1. Next, the function is f1 minus x square into e raised to minus I omega x dx. We know that e raised to I theta equal to cos theta plus I sin theta. So, write e raised to minus I omega x in that form, cos omega x minus I sin omega x dx. Then separate the terms. we get 1 minus x square into cos omega x dx minus I into integral minus 1 to 1 minus x square into sin omega x dx. Here the interval is from minus 1 to 1. So we have to check whether the function is odd or even. Here 1 minus x square, when we put minus x instead of x, the function have no change, so this is an even function. We already know that cos is an even function. Even into even is an even function. So integral minus 1 to 1 can be written as 2 into integral 0 to 1. Then next term, in next term 1 minus x square is even function, but sine is an odd function. Even into odd function, so the integral value becomes 0. So we have only one term, and that term is 2 into integral 0 to 1 minus x square into cos omega x dx. Here we have to use the integral uv method. Using that formula, integrate the values and substitute the limits. We get f of x is equal to f of x is equal to 2 into root 2 by pi sin omega minus omega cos omega by omega cube. So first question, answer to the first question. Next we have to prove that in using inverse Fourier transform, we have to prove the equality. Using inverse transform, we have to prove the inequality. For that, first write the definition of inverse Fourier transform. The definition is f of x equal to 1 by root 2 pi integral minus infinity to infinity f of Fourier transform of f of x e raised to I omega x d omega. Here f of x is, we already get that value. Substitute that value here, and 2 into root of 2 by pi is constant, take outside. Here the interval limit is minus infinity to infinity sin omega minus omega cos omega by omega cube. Here also e raised to I omega x can be written as cos omega x plus I into sin omega x d omega. Then next step, separate the terms. We have two terms and check whether the function is odd or even in both the terms. First consider sin omega. Sin omega is an odd function. Next cos omega is an even function, and divided by omega cube. Omega cube odd power terms are odd function. So odd into even, odd function. Odd by odd is an even function. So this limit can be written as 2 into integral 0 to infinity sin omega cos omega x by omega cube d omega. Then next term, omega is an odd function, cos even, cos omega even function, omega cube is an odd function. So odd by odd even function, then all other terms are even. So even into even function, that also can be written as 2 into integral 0 to infinity that term. Then next third term, sin omega odd function, sin omega x odd function, omega cube odd function. Odd into odd even, even by odd function. So this value becomes 0. Next term, omega odd function, cos omega even function, sin omega odd function, omega cube odd function. So this term also becomes 0. The last two terms become 0. Here take 2 outside. So 4 by pi into integral 0 to infinity sin omega cos omega. Denominators are same, so we can combine the two terms. Sin omega cos omega x minus omega cos omega x by omega cube d omega. Here we need not to no need to integrate the term. We have to just prove the equality. In that equality, the term in cos omega by 2. The term is cos omega by 2, but here cos omega x So to get that term we have to put x equal to 1 by 2. So put x equal to 1 by 2 in both sides of the equation. So pi by 4 into f of 1 by 2. Here f of x is 1 minus x square. So f of 1 by 2 is 1 minus 1 by 2 whole square. Here only here we have to put x equal to 1 by 2. Then 1 minus 1 by 2 whole square, that is 1 minus 1 by 4, that is 3 by 4. From this we get the answer 3 pi by 16. Okay.